Good morning, everybody. My name is Mark Lubkowitz, and welcome to Lub Goes Live. I'm a molecular biology professor at St. Michael's College, and I've been making videos on COVID-19 and other sciencey stuff for my students that are in molecular genetics and who have made some suggestions on what might be worth sharing. And today I want to talk about convalescent plasma, which is an idea that is being bounced around, and I think actually is being tried as a treatment, particularly in New York City, which is where I first read about it in the New York Times. So without any further ado, let me share my screen, as I always like to do, and let's talk about convalescent plasma. All right, give me 1 second here if you could, please. Boom. All right, so let's start off. Convalescent plasma, what is it? And is there evidence that it might work? And for those of you who are curious, the structure right here is an antibody. And if you watched the last Lub Goes Live, we spent quite a bit of time, in fact, the whole time on antibodies, and that's going to be part of our narrative today as well. So brief review of antibodies, because this is what this story is all about. So let's say that an individual contracts COVID-19. So here we have the viral particle that I clipped off of the internet. When that enters your body, or when any foreign agent enters your body, you have a population of cells that are called naive B cells. These B cells have not taken on a fate in life yet. And so they have the genetic potential to make across our whole genome about 1 trillion different combination of what are called antibodies. So this naive B cell over about 10 to 14 days will decide its fate in life, and it will become a plasma cell. The plasma cells then make and secrete these proteins that we call antibodies. Antibodies, they literally look like a Y, as you saw in that last image. That's what one really looks like. And their job is to bind to foreign agents, so something that is not supposed to be in your body. And when they do that, they essentially paint it very similar. I like to think of it as being analogous when a Navy SEAL is painting a target to be bombed. So in this case, your antibodies paint a target, and the bombers in this case are your immune system. So anything that gets painted by antibodies gets attacked by our immune system. And believe it or not, your immune system is remarkably effective. And if you can paint a target that is by virus, most of the time, not always, but most of the time, your immune system will win. Okay, so the big idea is if you have antibodies in your body, let me move my little screen here so everybody can see my writing there. So if you have antibodies in your blood that recognize COVID-19, that means you've had the virus. And here's the big one, If you recovered, it's because you made the antibodies. So anyone that has recovered from COVID-19 has antibodies that are effective against that virus. So here's the idea with convalescent plasma. So you have an individual who at this point is nice and healthy, and they get COVID-19. They get sick over the course of 2 to 3 weeks. They recover. Yay, I survived the virus. Then at this point, you have another individual who comes down with COVID-19, and you isolate the antibodies from the individual that recovered, and you inject them into the sick individual. And of course, the $1 million question is, will it work? Will they have a better outcome? So, as always, if this idea just didn't come out of nowhere, is there evidence to suggest that this approach might actually work? So I went into the primary literature, and I found this paper that was published in 2004, and it was on SARS, which is also a coronavirus, related virus, slightly different mechanism, but genetically related in the same family. And this was published in a journal called Clinical Microbiology and an Infection. And if you've seen any of the other Lub Goes Live, the first thing you want to ask is, how reputable is this journal? So the impact factor of this journal is 6.4. For comparison, the Journal of the American Medical Association is around 30. Some of the other journals that we were looking at on other Lub Goes Lives had impact factors in the 20s, Science and Nature's in the 30s, and so on. So 6.4 isn't great. Doesn't mean that this isn't true. It just means that this is not on the pecking order of journals. It's not at the top. So this is an image or a table that I clipped out of this article. I just want to point out a couple things. Let me get my little spotlighter here. So they're doing 2 things here. They have a control. The control is just getting steroids. So steroid treatment is the standard treatment for SARS. And then they have a group that is also getting this steroid, but in addition is getting antibodies from people that have been that have overcome SARS. Now, the individuals in their study are individuals that are in ICU. So these are people that are really quite sick, and they're measuring success by, do you recover after 22 days? Right. So in their group, well, let's start off with the control. So in the group that only received the steroid, 19% recovered compared to 73% that got the antibody for something else. But, and here's the big but, look at the sample size. So I only had 14 individuals that recovered compared to 4 that recovered here. And the total size of their study is 13 individuals in the control and 18 in the plasma group. These are tiny, tiny sample sizes. Let's keep going though. So if we just look at the death rate, no one that received antibodies died, but once again, just a caveat, that the sample size was 18 patients. And then, what was it, 5 patients that just received the steroid did die, but once again, the caveat is notice that it is only 13 patients. Okay, so what does this mean? I mean, it's suggestive, but certainly not definitive. So then I went and I looked at, let me get rid of this part here. I went and I looked at another study in an unrelated virus. And this study was published in the New England Journal of Medicine. It has an impact factor in the 30s. But once again, it's looking at Ebola, which is not related genetically at all to COVID-19 or to SARS, and it has a completely different mechanism of action. And interestingly enough, looking at close to 100 patients to which they gave antibodies, it did not work. There was no difference compared to the control. That may or may not mean anything. It certainly suggests that convalescent plasma or antibodies are not going to work in every case. It didn't work in Ebola. They seem to work with a very small sample size in SARS, but that certainly is not definitive. Okay, so what does all of this mean? Let me stop sharing the screen so I can look at you guys again. So what does this mean? Well, it means that there's evidence to suggest, certainly not to prove, that convalescent plasma may work for COVID-19 and is probably worth pursuing and actually is being pursued in clinical trials right now. Okay, that's all I got for you today. Once again, I'm Mark Lupquist from St. Michael's College. You can learn more about me in St. Michael's online. And as always, trying to rise from the ashes like the phoenix. And remember, let crisis bring out the best in you. See you soon with Science and Nature.